All right, lesson 3-1 was over understanding relations and functions. So the objective for today was to be able to identify whether a relation is a function and then interpreting a function. So for the first example, it was over identifying functions using arrow diagrams. So they're going to give you some information. You're going to put it into an arrow diagram and decide if it is a function or not. So for this first example, Jonah is shipping 5 boxes for his uncle. Each box is the same size but a different weight. The cost to ship each box is shown in the diagram. Should Jonah expect that the cost to ship a 15-pound box will be a unique cost? So for this, we're going to start by organizing all of our data into ordered pairs. Whenever you have a function or any relation, you have an input and an output. Your input is also your x value of your function, and your output is your y, just like we did back in the last chapter with linear relationships. So looking at this specific relation, our input is going to be the weight, and our output is going to be the cost, because the cost depends on our weight. So our weight is the independent variable, and our cost is the dependent variable. So going ahead and putting these into ordered pairs, we would have 8, 856, and then we would have 9, 872, 10, and 901, 12, and 955, and 14, and 1003. Any set of ordered pairs like this where there's an input and output is called a relation. So there just has to be two units that you're talking about. Are we talking about weight and cost, distance and time, those types of things? So that's a relation. Now we're going to look at this information and decide if it's not only a relation, but is it a function? So to do that, we're going to use something called an arrow diagram. So when you're using an arrow diagram, on the left side, you always put your input. So this inside of this oval, we're going to put our input values, and on this side, we're going to put our output values. So for my input values, if I look back at my diagram or my ordered pairs, I had 8, 9, 10, 12, and 14. And then for my output values, I had 856, I had 872, 901, 955, and 1003. And with the arrow diagrams, what you do is you draw an arrow from the input to the output that corresponds with that specific input. So for 8 pounds, it was 856. For 9 pounds, it was 872. For 10 pounds, it was 901. For 12 pounds, it was 955. And for 14 pounds, it was 1003. So since each one of these inputs has their own arrow going to only one specific output, we say that it is a function when each input has exactly one output. And that's the definition of a function. So sometimes you're going to notice that you have an input that maybe has 2 arrows going from maybe 8 to 856 and 8 to 872. If that happens, then that would be considered not a function. So the question for this word problem was, can he expect that the cost to ship a 15-pound box will have a specific cost? Yes, because as we can tell from all the other weights, they each have their own cost, so he can expect that for a 15-pound box, it will have a special, unique cost. All right, example 2, using tables to identify functions. So this is another way that you can look at functions. So for this, you're going to see if each input has its own output. So Frank uses this table to record the ages and heights of 6 of the students he tutors. Is this relation a function? So the age is our x. These are our inputs. and our heights are our outputs. Again, your height is depending on how old the child is. So looking at this, I have inputs here. Notice that I have 9 and 10, 2 9s and 2 8s, and that's okay. We can have more than, you can have a repeating input that's happening here. If I go ahead and look at these numbers, I notice that this 9-year-old was 54, this 10-year-old was also 54, then I have another 9-year-old that was 61. So if you'll notice, the input of 9 has 2 different outputs, and because of that, this is not a function. It's not, every 9-year-old is not always going to be the same height, so this is not considered a function. A function would be saying that for every age, there's only one height that you can be, which isn't true. So for this one, no, this relation is not a function. Okay, and again, the reason why, if you look at these 2 9-year-olds, they have different heights. Okay, so, and then the same thing with the 8-year-olds. These 2 8-year-olds have different heights. So again, there's another spot where it's not a function. It's not something that we can predict. Okay, and then the final example is interpreting functions. So Heather and her parents are going to an art museum for the day. The parking garage near the museum charges the rates shown in the sign. Is the cost to park a function of time? So is the cost a function of time? So for this, you're looking at your input. For this, our input is our time, because the cost to park is depending on how long they are parking. So this time is our input, and our cost is our output of our function. Again, that's the same as saying x versus y. So they're asking, is the cost to park a function of time? So for this, you're looking, does each hour have its own specific price? There's not, it's not saying for 1 hour it'll charge $5 or $7, or at 3 hours it could charge $15 or 18 hours. There has to be one cost for each hour. So is the cost to park a function of time? Yes, because if you look at each hour, they have their own specific time. So each hour has a different cost to park. So this would be considered a function. If they stay at the museum for 6 hours, should they expect to pay more than $25? If you're looking at the pattern that's happening, you can see that as the time increases, so the longer you're parking at this museum, you also notice that the prices are going up. So based on the information that's given, they can expect that they're going to pay more than $25 because they're going to be parking there for a longer time. So this function, you can kind of see, is increasing as the time increases. So yes, you can say as the time increases, so does the cost. Okay, so that's just a little overview of beginning to look at functions. This chapter is all over functions, so just looking at input versus output, and that you can only have one output for each input. Okay.